Ionocaloric cooling. A new era in refrigeration. Scientists have developed a revolutionary new refrigeration method called ionocaloric cooling, offering a potentially safer and more environmentally friendly alternative to traditional systems. This breakthrough, pioneered by researchers at Lawrence Berkeley National Laboratory and the University of California, Berkeley, could reshape how we cool everything from homes to industrial processes. The problem with current refrigeration, traditional refrigeration, relies on fluids that absorb heat as they evaporate and release it when condensing, a process effective but often using harmful refrigerants. Many of these substances have high global warming potential, GWP, contributing to climate change. The Kigali Amendment commits nations to drastically reduce the production of these harmful hydrofluorocarbons, HFCs, creating an urgent need for viable alternatives. How ionocaloric cooling works. Ionocaloric cooling leverages the heat absorption or release that occurs when a material changes phase, like ice melting. Unlike traditional methods, it doesn't rely on evaporation or compression. Instead, it uses ions, charged particles, to manipulate a material's melting point. Adding salt to roads in winter to prevent ice formation is a familiar example of this principle in action. The core idea involves cycling a fluid through phase changes using an electric current to move ions, effectively shifting the temperature. Researchers tested this approach using iodine and sodium salts with ethylene carbonate, a solvent also used in lithium-ion batteries. Notably, this system could be GWP negative, since ethylene carbonate production uses carbon dioxide as an input. Key findings and performance experiments demonstrated a temperature shift of 25 degrees C, 45 degrees F, using less than 1 volt of charge, surpassing the efficiency of other caloric technologies, which rely on heat changes in materials. The research, published in Science, models suggest this cycle could match or even exceed the performance of current refrigerants. Scaling up and future development, the biggest challenge now is moving this technology from the lab to commercial viability. Researchers are actively testing different salt combinations to optimize performance. A separate team has already published findings on a highly efficient system using nitrate-based salts, recycled using electric fields and membranes. We have this brand new thermodynamic cycle and framework that brings together elements from different fields. And we've shown that it can work, said Prasher. Now, it's time for experimentation to test different combinations of materials and techniques to meet the engineering challenges. This research represents a significant step towards sustainable cooling solutions. If successfully scaled, ionocaloric cooling could not only meet but surpass existing standards in efficiency, safety, and environmental impact.